Sixth grade Excel, lesson 23, recognizing similar and congruent figures, recognizing flips, slides, and turns, and recognizing lines of symmetry and bilateral and rotational symmetry. Okay, a lot of this should be review for you. Probably the bilateral and rotational symmetry is going to be brand new. So just pay attention and make sure you understand how to do these review items, and then that you catch on to the new stuff as well. Two figures that are similar have the same proportions but are not the same size. The symbol shown between each pair, this right here, means is similar to. So this pentagon is similar to this pentagon. It is not similar to that pentagon because this one's all stretched out. Basically similar means that they look exactly the same, only one shape is larger than the other one. So this shape right here looks like it was put on a copy machine and shrunk down to look like this. And that means they're similar. All right, here is the next part. Two figures that are congruent have angles and lengths of sides that are identical. They're exactly the same. The symbol shown between each pair looks like this, means is congruent to. This one is congruent to that. So two shapes that look exactly the same, not one of them bigger than the other, but they're the same size. I mean, you could take this shape here, put it right on top of that one, it would match up perfectly. And so those shapes are congruent to each other. You can see we have the equal sign with a little squiggly line across the top. So let's keep going. If a figure is moved to another position, the change is called a transformation. And many of you already know that transformation means change. So you can transform a figure with a flip, called a reflection, a slide, which is also called a translation, or a turn, which is called a rotation. A flip, or a reflection, occurs when a figure moves across a straight line so that the new position is a mirror image of the first position. So you can see we start off with this shape here, it comes across over to here, and it flips it. So this corner comes over to that spot. That's just flipping it over, and we call that a reflection. Just like this is a mirror, and this triangle is looking at itself in the mirror. The new position is the same distance from the straight line as the original position. Notice that these are equidistant away from that dotted line right there. A slide or a translation occurs when a figure moves without changing its appearance. So here we have an octagon, and it just slides right over here. It looks exactly the same. It hasn't flipped, it hasn't twisted, it hasn't done anything, just slid right across. So we call that a translation or a slide. A turn or a rotation occurs when a figure turns around a point. So here we have a square, and that turns over this direction, keeping this in one spot. It's kind of twisting, and so we call that a rotation. These are pretty easy to understand, but maybe not so easy to remember. I'm sure you'll catch on to them after a while, though, from doing your guided practice in your homework side. Okay, so more review. I'm sure you've learned about line of symmetry before. It's an imaginary line that divides a figure in half. If you were to fold the figure along the line of symmetry, the two sides would line up exactly. The two halves would be mirror images of each other. This concept is referred to as bilateral symmetry. Bi means two, and so what we're saying is that two, both sides, match up exactly. This rectangle has bilateral symmetry right here, because if I were to fold it right here, this corner would match up with that corner, this corner would match up with that corner, and it would just match up exactly perfectly. And that's called bilateral symmetry. Same thing with this direction. If I fold it here, this corner is going to match up with that one, and this corner is going to match up with that one. It's going to work out perfectly. Now let me get all this stuff off the screen and show you. A lot of people think that this on a rectangle is a line of symmetry, but it's not. And one way you can prove that is this is the shape of your Excel paper that you're working on right now. You can try to fold right along this diagonal, and you'll see that this corner here is going to stick out kind of like that over there. And when this corner comes over here, it sticks out kind of like that. And so that is not a line of symmetry, either diagonal direction on the rectangle. But on a square, it does work that way because this corner is going to come over and match up with that corner. Or if you fold it right here, then this corner is going to come over and match up with that corner right there. So a square actually has 4 different bilateral lines of symmetry. The type of figure determines whether this is possible or not. So you can see this shape here, there are no lines of symmetry. Think of your body too, as it's got one line of symmetry down the middle, unless your hair is not, you know, or maybe you're missing an eye or something. Just kidding. Okay, so your body, if you were to go right down the middle here, you have an arm that matches up with an arm, a leg that matches up with a leg, eyes that match up with each other, ears that match up, your mouth, half of it each side, and so on. So your body really is a perfect example of symmetry, bilateral symmetry. All right, a figure has rotational symmetry when it can be rotated to one or more positions before turning 360 degrees around its central point and still look identical to the original figure. It can cover itself completely. So this one's kind of tricky. This is probably new to most of you. That is very confusing, but I think you'll understand it when you see me explain it in a second. The order of symmetry indicates the number of different positions to which a figure can be rotated to match itself exactly. If there is at least one rotated position, then the original position is counted too. Regular figures have an order of symmetry equal to their number of sides. We talked before about like a regular pentagon. A regular pentagon has 5 sides, so its order of symmetry is 5, since that's a regular shape. For example, a square has order 4 and a regular pentagon has an order of 5, like I just showed you right there. All right, what's all this stuff talking about? Rotational symmetry, order of symmetry. All right, what I've done here is drawn a large star on the board, and I'm going to show you some rotational symmetry and order of symmetry right now. Does this star have rotational symmetry? And the answer is yes. I'm going to spin it around, keep track by looking at it right up here at the top. That's what's called like the head. In fact, let me see if I can put a mark on top of that that will stay. I'm not sure if that'll work or not. Let's see if I can actually put a little mark on there. Okay, we'll see if it stays on the star. Probably won't, but we'll give it a shot. Let me see if I can actually group those together. And, well, anyway, here we go. Rotational symmetry. I'm going to move this way. And as you can see, when I get to there, it looks the same as it did when I started with it. Well, kind of. It's not. It needs to be stretched out and made a little bit more. Okay, so now it looks the same. And then that's one move. So we're going to say that it does have rotational symmetry. And that's 1 so far. And then I keep going 2, 3, 4, and 5 back where I started again. So this shape has rotational symmetry, and it has the count, an order of 5 for that shape. Now let's take a look at some other shapes and see if they have rotational symmetry, those that are on your paper right here. Does the letter A have rotational symmetry? Well, if I were to spin this around like this, I would not have it look just like that A until I came all the way back to the beginning. If it's upside down, it's not going to look like an A. And so I'm going to call this rotational symmetry of 0. It has an order of 0, and which means it does not have rotational symmetry. How about the letter N or Z? I guess you could call it a Z. I want you to pause the video and see if you can put a number in here of what you think the rotational symmetry of that shape is. Okay, what you should have said is that we can actually spin this around. If I spin it around one time, it's going to look just like it does now with this here and that there. And then I keep spinning back to where it started, and so it has a rotational symmetry of 2. Now pause the video and see if you can figure out what the rotational symmetry of number 3 is. Okay, well, this point here, if I spin it around, is going to come up over here, and that point is going to come down there, and it's going to look exactly the same. And I can actually do that 3 times before I get back to where I started again. So the rotational symmetry on that is 3, just like I showed you with the star up here. All right, thanks for watching.